Hey guys, this is Mrs. Mindy, and today I'm going to introduce you to some atomic structure. And you may have seen this before, so if so, this is just going to be a little refresher, but there'll also be some things which I'm pretty sure you have not seen before. Okay? Atoms are the smallest particle that is still an element. So if you get any smaller than an atom, these subatomic particles that are here, these aren't for any particular element. So if you get any smaller than these, it's not an element. The element is this whole atom. It has to be at least an atom to be any particular element. Atoms are small, really, really small. So about 100 million of them, and they're different sizes, but about 100 million of them in a row would be 1 centimeter long. So definitely not any big than your pinky finger, like the width of your pinky finger. Atoms are much, much too small to be seen with a regular microscope. So I'm going to do this little interactive with you to show you how small we're talking about. Let me switch to another window. Okay, so we're going to go over here and you can see that we're starting with things that you can see with your naked eye. So no microscope or anything. You can see a coffee bean, a sesame seed like on a bun, or a single grain of rice. And I'm going to use this slider and we're just going to zoom in. Okay, so now we're getting to where there's a grain of salt, and you can certainly see grains of salt. And just a little bit smaller than that is a pretty big cell. So that's an amoeba and paramecium, and both of those things live in pond water and other places. And then the biggest human cell, a human egg, that's the biggest human cell that there is. And for comparison, there's a sperm and there's some other cells, skin cells. Now, let's see that little red one? We're zooming in smaller, smaller, smaller. There's a red blood cell and then an X chromosome, baker's yeast, like it's in the bread that you eat. And then we're getting down to some smaller stuff. So here's a mitochondrion, which you may remember from when you learned about cells. They always call it the powerhouse of the cell. And then a bacteria, which is almost exactly the same size as a mitochondria. Lysosome, so there's some other little cellular parts. Now we're getting into some small stuff. So viruses are much smaller than regular cells. So here's a measles virus, flu virus, influenza is its fancy science name, HIV, a phage, which is a virus that only infects bacteria. And then we go down. Rhinovirus is the cold virus, hepatitis, which hurts your liver. And then the ribosome are they look like little dots usually inside cell diagrams, and they make proteins. And then there's antibodies that help you fight disease, hemoglobin that carries oxygen and carbon dioxide in your red blood cells. And now we're getting down to some really smaller stuff. So there are some parts of cell membrane and amino acids and nucleotide, a little piece of DNA, um, glucose, sugar, and then there's a water molecule. And now we're getting where we can see individual atoms. So this is how small they are. There's a water molecule and a carbon atom. And that's really how tiny we have to get. So let's zoom back out. So the carbon atom, look at it. Okay. Oh, and now you can't even see individual atoms. Ribosomes, which are so tiny, viruses. Okay, and now the viruses are too small, and now the bacteria are getting too small, and now we're getting to where we can see things. Okay, so that's what we're talking about. That's how tiny. Okay, now atoms, let it catch up. Atoms have a nucleus. Okay, and in this nucleus, there are two kinds of atoms. I'm sorry, two kinds of particles. It's a bundle of protons and neutrons in the middle. Okay, so protons are positive and they live in the nucleus. The neutrons are neutral and they're in the nucleus too, all stuck together with the protons. The electrons are negatively charged and they go around the nucleus, so they are never in the nucleus. Some of these parts have an electric charge. So the protons have a positive charge, and because of that, the nucleus has a positive charge. The electrons have a negative charge, and they're around the outside. So the outside of an atom is always negatively charged. So just as a little reminder, what three particles make up an atom? You remember? It's protons, neutrons, and electrons. We're going to practice that about 1,000,000 times. The atomic number is the number of protons in an atom. So every element has a different number of protons. That is what makes them different. That's how we define it as an element. The electrons and the neutrons sometimes change, but what really makes it any particular element is the number of protons. So that's why we call it atomic number, and you will have to know that later. What three particles make up an atom again? Protons, neutrons, and electrons. Okay, one proton has about the same mass, so it's about as big as one neutron. There's a tiny little difference that maybe you'll learn about later on in like big time chemistry. Um, but just for now, assume that they are the same size, the same mass. And notice that electrons are teeny weeny compared to protons and neutrons. Do not memorize these numbers. Do not write these numbers down. Just remember that protons and neutrons are big and the same size, and electrons are teeny weeny compared to them. So they're about 1,000th as big as a proton or neutron. Each box in the periodic table, and you may have seen a periodic table in a classroom like mine, and it kind of looks like this, and there's a lot of little boxes with stuff in them, and each box has an element in it. So each box in the periodic table has stuff about that element. So here are some things that you do have to know. So up usually on the top and written in a bigger font is the atomic number. Now, the atomic number is the number of protons, we just said, but it's also the number of electrons, so it's balanced. The symbol is in there, so this is helium. Sometimes it'll have its name written too, like down here where it says the word helium down here at the bottom, and this will usually have some decimal places in there. That's the atomic mass, and that's always going to be bigger than this number up here. Not bigger in size, but a bigger numeral. Okay? In atoms, and I said this a second ago, but just to emphasize this, because this is really important, the number of protons is equal to the number of electrons. So if you know the number of protons, you know the number of electrons. Mass number is another thing that is important to know about an atom, and it is the number of neutrons plus the number of protons, and that's the mass number. Um, you can see the mass number from the periodic table from the atomic mass. So the atomic mass is down here. This one has a very precise number. But if you round that number up to the nearest whole number, not necessarily rounding up, not necessarily rounding down, but the nearest whole number, that's going to give you the mass number. Okay? So this is 22.9 and some change, that would round to 23. So that's important. Why is it important? Why do you care? It's because you can use the mass number to calculate the number of neutrons, because that won't be written on the periodic table. You'll have to figure it out. So if you've got the mass number, which you get by rounding the atomic mass, minus the number of protons, which is the atomic number. That's how you'd know that. So the mass number minus the number of protons equals the number of neutrons. Okay, that's it for today.